is line number 29. This card number is OCPX 80235. And again, this is another vinyl chloride car with the same outcome. No mechanical breaching. Another vent and burn car. Third car, hazardous materials, the OCPX 80179. This is another vinyl chloride car, and again, the same outcome, vent and burn, no mechanical damage to the vessel itself. Fourth car number 31 in the lineup. This is GATX 95098. This is the fourth vinyl chloride car in the initials pileup. And again, same outcome. It was a vent and burn with no mechanical damage to the vessel. The next car, hazardous material car, was line number 36, card number SHPX 211226, and this was an ethylene glycol monobutyl ether car. This car lost its entire load. Due to the bottom outlet valve being dislodged during the derailment. So we had loss of contents through the BOV, and on the B end of the car, the tank head had a crack in the head itself from the initial derailment. The next car in the hazardous material lineup, car running order number 38. This is a DOWX car, 73168. This is the ethyl hexyl acrylate car. What was reported was that there was a partial load loss, and we had both B head. We had the A end had a head puncture, and the B end had cracks on it. So again, we had breaching of this tank car, when it was involved in derailment itself. Next one is line number 50, UTLX 205907. This is a butyl acrylates car, and the A and B end had punctures, and this car was also observed in numerous photos of the drone flights and whatnot, that the manway gaskets were burned out on this car, and you could see some of those fires as the car was laying there post derailment. Next hazmat car, line number 55, OCPX 80370. This was the fifth vinyl chloride car in the consist, and again, no mechanical damage to the car, and this was the fifth car that was vent and burned during that operation. And that concludes the hazardous material tank cars. The next table I'm going to refer to is table number 10 within the same exhibit. And this is page 57 of the document, table 10, and these are the non-hazardous tank cars that were involved in the derailment itself. We'll start with line number 30, running order in line number 34, an RACX car 51435. This is a propylene glycol car, a DOT 111, 100W1. Head impact damage, puncture to the shell on the left center of the car, and it lost its entire load. The next car would be running order number 41, UTLX 100055, a petroleum lube oil car, DOT 111, 100W1. The manway cover was missing, the top fittings sheared off, and the tank shell on this one was also punctured. Car lost its entire load. Next car, running order number 42, XOMX 110664.
And what role did the tank car construction details play in considering how to address the hazards posed by the various tank cars, including the vinyl chloride tank cars? Did you reference UMLR data or any other data for the tank car certificate of construction or anything while you were in the process of doing this remediation work?
Yes, after the initial derailment, we looked up the car specifications in UMLR, which revealed that they were all 105 J300Ws, so we knew what minimum thickness they were. We knew they had thermal jackets. We knew they had 1/8 inch steel jacket. We knew they had protective housing around the valves. So that gave us an idea of what type of container we're dealing with. We also looked at the properties of the vinyl chloride, and it was a suitable container.
Okay, and did you do that for all of the tank cars involved in the derailment?
Yes, sir, we did.
Okay, and so I guess it goes without saying that the UMLR data needs to be accurate. Where does that data come from?
The UMLR data is entered by the car owners, and it is stored in Rail Inc.
Okay, and did you find the data to be accurate and consistent with what you found on scene?
To my knowledge, yes.
Okay. All right, Ms. Stegman, I heard your preliminary statement regarding the performance of the tank car equipment, and just want to give you the opportunity. Is there anything else you would like to say about them, given the outcome in this incident in which there was a need to conduct a vent and burn on your tank cars?
I have nothing to add to the damage assessment, but when we look at the vinyl chloride cars, there's just a few key points we want to continue to emphasize. Mr. Stansel, you opened up panel 2 yesterday with a definition of pressure relief devices and a description of their function. The primary focus, the only focus of a pressure relief device is to relieve the excess pressure building in a vessel or tank to prevent a rupture. That is exactly what the pressure relief devices on all 5 tank cars did. It's the one fact that is very clear throughout the derailment and the incident that occurred. The 5 pressure relief devices were activated. That's according to eyewitness testimony. And the tanks remained intact up until the vent and burn decision. That was over 60 hours that the 5 pressure relief devices protected the 5 DOT 105 tanks. Thank you.
Okay, thank you. So since this derailment, have you identified any issues at all that point to the need for any changes of processes, procedures, or equipment for your tank cars?
No, we have not.
Okay. All right, thank you.
Vice Chairman Landsberg.
Thank you, Chair. Mr. McCarty, is there any way to determine the amount of liquid inside of a damaged tank car, sort of like you do with a propane gas tank for a home grill situation, so you might have some certainty? I realize you've got jackets and things in the way, but...
So the answer is sometimes yes, and sometimes in this case, no, there wasn't a safe way to get it. Some of these cars, as I recall, did have gauging devices on them, but they were fire damaged and inoperable. For us to get that information you're looking for, we'd have to physically get people in there with either cold cutting equipment or torch equipment to peel off jackets. And once again, you're into kind of an extended operation and unknown mechanical damage. In cold cutting, it would have been a series of vibrations with a cold cutting, cold work machine that just, we didn't want to add vibrations to cars that we were concerned about that could have had cracks or things we didn't understand yet, or that we didn't know about yet, and hidden damage. And in hot work, there was so many flammables that were kind of igniting, going out, reigniting, going out. We didn't want to get a torch person in a flash fire trying to remove jacket. So sometimes in certain wrecks, we can remove jackets and do some thermal imaging. In this case, we just didn't feel comfortable putting people in there.
It's a dynamic situation. Last question on hot tapping. So I'm quite intrigued about the drill. Does the drill operator have to stand right there, or can it be done remotely?
No, it's another spot-on great question. You essentially have to dig somewhat of a work pit, and inherently that was another factor in the thought process with all the burning and residual flammables and chemicals in the spillage. That was another factor in the thought process, because you would have inherently had to have your welder and support people in a trench with burning and oozing stuff coming into the trench in the lowest parts around those cars. So that was certainly another factor in the consideration as to the safety of considering hot tapping.
Okay, thank you. This would be for Dr. Carroll or possibly Mr. Thomas. From the vent and burn, we know that there was a significant amount of a cloud that was formed. And so could you tell us a little bit about the fallout from the cloud in terms of toxic chemicals and things of that nature?
Once again, it would be good to have data because there are samples that can be had of those kinds of plumes. But we've talked about the chemical products of combustion, the carbon monoxide and HCl and possibly phosgene. The black cloud is essentially polycyclic aromatic hydrocarbons and carbon. I mean, it's carbon black, it's soot. It's difficult to speculate about other materials. When I say polycyclic aromatic hydrocarbons, I mean a plethora of individual chemicals that we just sort of generally refer to as soot. So that's what mainly comes to mind for me. Are there other things that you were thinking of?
Well, I'm just curious, in terms of, was there any, obviously, I would hope there would have been sampling done downwind of, what actually fell out of the cloud in terms of the chemical composition. And so as we're trying to learn as much as we can from this tragedy. And so what did you discover, if anything?
My recollection of the bits that I saw was that they did try to sample for phosgene and didn't find any. But other than that, I don't have any specifics of air monitoring that was done.
Or ground monitoring.
Or
ground.
Or ground. And in this case, as was testified to, this would probably not be an issue for soil because the vinyl chloride would evaporate. It's a vapor at ambient temperature. So it's not going to run into the ground and then into the groundwater. And I do think there was some ground sampling that was done and didn't find any.
Okay, thank you very much. No further questions, Chair.
Member Graham.
Thank you, Chair.